Alright, this is the introduction to Piloslib, the multi-platform open source set of audio and modulation tools built in Pure Data. I'm going to take you through them and kind of show you how things are built with it and the conventions. So the objects are going to require the objects contained in plate to function properly. So if you want to get started, you got to start with plate. Intro also has those objects and an explanation for it, so that might be helpful to start with. All the examples do have those objects as well, so I'm just going to take a look at plate itself. This is the most bare bones patches you get with it. Starting top down, this is just a bar and beat readout. The save and load system is here. So in order to save properly, you have to hit this save first before saving to the patch, and it will take all the values that you have set in your interfaces and put it in this message box. You can see it's just the tempo right now. So that will save it. Load happens automatically. Declares in case you don't want to add all the folders to the patch, but it will only work if your patch is in the root folder or one of the subfolders of Piloslib. Otherwise, you do have to set those in Pure Data, set the path in Pure Data. Then you have the global transport, which is going to handle playing, stopping, and your clock. You can tap tempo, play, reset and play to take it back to the beginning and stop. And then this will nudge you forward and back if you're trying to sync externally, change your tempo. And then there's a clock readout here, and it's 1/24ths of a beat or 1/24ths of a quarter note, so it's the same as a MIDI clock. And you can scrub that as well in case you want to go forward or backwards. And then yeah, bar readouts here for longer lengths of time. Then dealing with the audio, you have a catcher here is how it starts, and that is just going to set up variables to the name master here, and these are used to receive audio from channel objects or anything that you send to master in or master left in, master right in. That is going to get sent to a tan-HX, which is just a non-linear compressor to kind of smash the audio together and prevent any speaker blowouts. And of course you can add audio anywhere in this process if you want to skip any of this. High pass filter at a very low frequency, a sub-audible frequency, just to get rid of any artifacts or DC offset. Then from here it splits in three, your main audio, and it goes first to this write SF global, which is going to write to a sound file aligned with the global clock. So when you hit play, it'll start recording or reset and play, and then it will keep going until you hit stop, but that is only if you have it enabled like this. It also sends to some peak readouts. These are disabled by default, so you have to hit that toggle to the left of them to get them going, just because they are fairly CPU inefficient. So if you use a lot of peak meters, I would recommend just using some externals for that. Then the audio is sent also to this T line, which is times line. So it's similar to just a times tilde object where it will multiply audio by a certain amount, but the amount is a control signal, so it's not audio that you send in. It's a control signal to multiply that audio, and it gets a line to a line to not frap or anything. It'll just smoothly move to different areas. And you can see this is 1 by default. This is a 0 to 1 slider, not 0 to 127. So, and most sliders you'll see from me are 0 to 1. I build them that way usually, and I have a shortcut key, auto hotkey to just build them 0 to 1 automatically. So this is just multiplying it by 1, so doing nothing unless you want to turn down your master volume. But it also sends on load a bang to turn the DSP on for pure data, so you'll start hearing audio right away. And then from there to the DAC, and that is the objects in plate. You can always go into the intro file to get a written explanation for them as well. And yeah, let's build some objects. So start with a simple sine wave, turn it down a little bit, and this I'm going to make a channel object, so chan 1 by 2, because 1 input to 2 outlets, or you can do 2 inputs to 2 outputs. So channel 1 by 2, and then VVCM, and I'll explain what that means in a second. And then the first argument is the name for the channel, so we can just say example chan. So this is sent to the example chan, and you can hear that automatically because we already have that master set up that this will send to. Yeah, and let's make a effect here, and I will walk you through the VV, VVC, VVCM objects. So you can make a simple bit reduction effect here. It's going to be controlled via the inlets, bits, dry, wet, and then the audio signal in. So you can control it this way, or most of the audio effects and a lot of other things you'll see have a VV suffix added to it, and that just means that it's going to create variables depending on what name. So we'll call this example effect, and now there are no inputs, but if you take a look inside, you have variables you can send to. So we can send to example effect bits to control it now. And if you want an entire object, a lot of them have a VVC object also associated with it on top of the VV object. There's no tilde at the end of it because there's no audio generated, because it's just a controller. VVC is your controller of the VVs or any set of variables. So I'm going to give it the same name as this one here, so it sends to the same variable. And then you can see this will control the amount of bits, the dry, and the wet. These are all HSLX NBX objects, which is a horizontal slider times a number box. So you have this 1 times 32. Remember, the sliders maxed out are usually 1, so this gives you fractions of 32 here. And then this is 0.5 here. That's all the way to 1 because you're multiplying by 1. Yeah, and then if you want to do stereo with effects, you can do it by creating, if they're going to be the same control, if you want the controlling both of them the same way, you can just duplicate your VV object, connect it, and we'll turn this channel into a the stereo, and then send it on over. And this will control both of them because it has that same name, example effect. Then there is one more of the VVC objects, and that is VVCM, and that is going to have this combined with this, so the VV combined with the VVC, because it contains the M, which stands for model, so it contains the actual guts of the bit reducer, as well as the VVC, which is just the interface. And the VVC is also how things get saved and loaded. So the reason you hit the save twice is so that these values get saved into the patch. But yeah, so the VVCM is a combination of these two objects. So in this example, I could just turn this into a VVCM, get rid of this, because this is replacing it, and this will control both this object and this object here, because it has the same name. And then you can see with this, again, the example effect of bits, you can still control them with that, but you'll see that doesn't affect the interface here. To do that, you append values with R, but this one's a little weird because it's a horizontal slider first and a number box, so this is just going to control the slider. And if you want to control the number box, you send in a packed value with a number and the slider. So, but for this example, we'll just go for it that way. So now it'll save with the patch, and it controls your interface because you appended the R to it to send to the interface itself. Yeah. And if that gets confusing, I know there's VV, VVC, and all that. You can always look in the intro. Patch does have a nice cheat sheet in the first box here. It summarizes all of them. So VV contains the object to control and the receive variables. VVC is your interface. VVCM, interface, and the model. And the model meaning whatever object you're trying to control. And then also it does get a little finicky if you have multiple plates open, just because you might overwrite variables of the same name and the global clock. Just having two of them, it'll run twice as fast. So if you want to copy things from plate to plate, just look here and follow these simple instructions. And as far as documentation goes, like I usually don't do help patches, I'll just do explanations within the patch. So if you see something like this, you see the bit reducer somewhere in the wild, and you don't know what this means, bit red, VVCM, just open it up. And there's no explanation here, so and there won't be in the interfaces. So keep going in. So bitred VVCM. I'll look in here. Nothing in there. So keep going within, and then you finally get to it. The bit reduction, reduce bits to degrade sound. So yeah, the explanations are going to be kept within the object that you're controlling itself, not within the interfaces. And then if you still don't see any explanation in here, I would look in the intro file, because that does have a lot of the stuff to get going, a lot of the information to get going. Yeah, so that's VVC, VVCM. Let's take a look at how to create a synthesizer. And synthesizers are usually fed note and velocity pairs. So you have two floating point values getting packed and sent into it to control it. So let's make two floating point values get sent in every beat, and how we're going to do that is with the B2N object, and that's just beat to bang. So every beat it's going to send a bang. That's of course aligned with the global clock. So you have beat to bang, pack 24, 100 to so send C with a velocity of 100 to our synthesizer. And synthesizers, as well as samplers or anything voiced, is going to be contained within a SYSK object, which stands for synth skeleton, and that is going to hold the synthesizer itself as well as the synthesizer and its voices as well as the interface. So we'll make a synth skeleton NV for N voice, so however many voices you want, and then VVCM because it contains the interface as well as the guts. First parameter is how many voices. We'll just say 3. It's not really important for the example. Second parameter is the type of synthesizer that you're going to build. We'll make an imp, very simple synthesizer. And then the last one is the name that you refer to and save. So we'll call it example synth. So that is sending into your synthesizer here. I'm going to turn this back into a mono input to stereo output, and then connect that and press play to get those beats sending. Oh, and a misspelled example out there too. Alright, so you can hear the synthesizer. Let's take a look inside the synth skeleton. So first thing is our VVC of the second parameter, so imp, it's imp's VVC here. And then the next thing here is the guts. You really don't have to worry about this. This is your voices here, so just stuff you're gonna send to. Yeah, it's just receiver variables that are going to be controlled by your VVC. So let's take a look at the VVC. This is a mod type MQU, and it tells you what all the modulators are: pitch, velocity, random, and the macro. So taking a look inside, you can see all the parameters have 4 subparameters, and that corresponds to those. So pitch, velocity, random, and macro. So you can set it to have a random FM every time. Or that's velocity, my bad. This would be random FM every time. And yeah, this will get saved and loaded with the patch because you have all your interfaces. Is there anything else I have to show it? Since they do usually come with a VV file, VVC, and this will save and load presets for the synth. You can call it whatever you want, and or even load whatever you want, and it'll try to match the parameters. Let's say you have a synth that also has a pitch envelope. It'll load up your pitch envelope stuff and just ignore what it doesn't have. So yeah, that's saving and loading of presets. And then samplers, you make it the same way. Just make this a sampler. But I'm not gonna do that there. Yeah, then I guess I will show just a simple sequencer to control this. I'll make more fancy sequencers, but right now most of them are controlled with the counter separate from the actual values that you're sending out. So I'll make a seek count VVCM, and this is going to count, of course, name it example seek. This is going to count 0 upwards to control whatever values you're going to send. And in this case, we'll just start sending floating point values. So we'll have a float 16x example sequence, and this will make just 16 floats that you can control externally. I'll make something over here for them. You can control them with any old sliders or number boxes or whatever, but what I'm going to make is an array of 16 number boxes, so NBX 16X VVC, because it's an interface for X seek, so it's going to send it to this because it has the same name. We can say add some numbers to it. And you can see it's kind of, well, why is that doing that? You can see it's going through them at a rate of 1 beat every step, and the length and steps kind of gets confusing, but the length can be above steps, and it will just wrap around to the beginning. So say you have even just 17, something simple, it will, what is that? Oh, I have my number lock. So if you have 17, it'll count through all 16, and then it'll look for the next one, but then obviously there is none, so it'll wrap over, because you have 16 steps, wrap over to the first one and do that. So it'll do 30, and then it'll repeat and do 30 again, or you could say do 20. It'll count through every single one of them, and then it'll count through the first 4, and then it'll wrap back around to the first one. So you can do some crazy polyrhythm stuff with that, but we'll keep it simple here. So like say the synthesizers are controlled with note and velocity pairs, so we will pair this float with a, well actually we'll get rid of our zeros, select 0. I do gotta move that out of the way. Select the 0 objects, and then I will pack the non-zero objects with a velocity here, and then send that into our synthesizer. Maybe speed it up a little bit. And there is a simple sequencer. There are more in the intro file, and I'll probably make a few more of them as well, kind of helper functions. But yeah, that is the basics of Piloslib. I'll fix this at the last minute here. But definitely let me know if you have any questions or comments or creations. Would love to hear it.